Okay, the next one, let's talk about how to use the linked list to implement our queue template class. Before we start, I want to review a little bit from last week, how we build up the stack using the linked list. If you remember last week when we start, you see we have the first node actually start from 0. So when we have a new node we want to create, we just create a temp node. So this node value will equal to the value we pass. So when we try to assign this temp node to the first node, we will have the temp next actually equal to the first node. So if this one, when first node equal to 0, you will see the first push node, they will have the next refer to the node because the equal to the first node, beginning first node equal to node. So then you will have the first node assigned to the temp. Again, the same thing. If we have the second push node, so this one is our second one. So the second one, whenever we create the temp, right? So then we will, the first thing after we create the temp node, so the first thing we were using the temp next to point to the where the first node is. So then after we done, we will have the first node assigned to temp. So in this situation, you will see the first node pointer. After the second one push, we will point to this one. Of course, afterward your temp will be, that's a local variable, so they will be disappeared. So that's why after we add more and more nodes one by one, you will see the linked list will look like this. That's actually, this one is the oldest one we push into the stack. So then the new one. So we will always add the new node here, the new node next point to the first node, then the first node to the new temp. Okay, so this one is for the stack linked list. We only need the first node pointer. The reason is no matter we push or pop, we all came from here. So now the same thing. How should we use the linked list for the queue? Like we say, queue, we need to have a pointer point to the where we will push, and also a pointer to where we will pop. Whenever we push in, actually the node will be the last one. Actually, it's the old, that's a new one we add in. So then actually, which one is really the beginning, the first node we push into the queue? Actually, we should pop from here. So that's why here you will see last week when we have our stack linked list, they look like this. So now when we update this one become a queue linked list, we need to consider how should we use this first node, and also we need to also add the other pointer to the last node. So now this last node and the first node definition is really the same. It's really what they really mean now, okay? Because the first node point to the earliest node we point to. So here actually is where we will pop from, okay? So here actually will be later you need to pop from here because that's really the oldest node here. So then here the last node actually mean is what? You point to the newest node you just add in. So that's why actually is where we should push from here. Okay, so that's why you will see that's the linked list for the queue. They should look like this. So that will be a little different from last week when we have our stack. Okay, our stack actually our first node always point to the newest node. Okay, so then actually that's our end of the stack. But here when we do the queue, right? So the queue actually our push and pop, they are one push to the end, one pop at the front. So that's why they will look like this way. So that's why actually not so much different. So one thing is the linked list, what we need from the stack implementation to the queue implementation. We just need to be careful is where you need to push, where you need to pop from. So now here is our linked list public interface for our queue. So you will see here your node still have value and the next. So I still have the size. I still need the dummy. So later I will show you the dummy. So now I will add one more pointer we call the last node. So then in your default constructor, you need to initialize this for data attribute. Because that's the linked list, we still need to have copy constructor, assignment operator, and the destructor. So later, right, so when we push, we need to push where the last node point to. So when we pop, actually we need to pop where the first node is. So then we don't have peak anymore because we can access to the front, we can access to the back. So actually this front, we just return the same thing. We will return a constant reference. So this one actually we can write as an inline function. Okay, so that's why you see actually your front, you will return the first node value, the value in the first node. So the back, you will return the value in the last node. Okay, so then here we have two inline function. Size, we just return size. Empty, we just check if the size equal to 0, so that's empty. So the clear, actually clear, you need to have the while loop. If the this one is either you do the first node or last node, but here since we pop from the first node, you just see whenever you have first node, then you need to pop from. So that's what we will see one by one. Okay, so that's the interface. Okay, so about the detail, how to implement each function, that will be in the reading and the lecture. So now I just go over one by one, so see what we need to pay attention. So here, you know the default constructor, we need to make the size equal to 0, first node equal to 0, last node equal to 0. The dummy, make sure you have your default constructor. Okay, so then these three we will talk in detail. So before we talk about push and the pop, let's see the front and the back first. So instead to moving to the next slide, I just write down the sample code here. Okay. So here I just say, for example, we want to do the from. Okay. About the syntax, I will leave you guys to write the function template function syntax because you should have much experience now. So you see the from, actually from we will pop from. The from actually is the where we pop from. So that's the first node. So if our first node not equal to 0, we will return the value. Okay, so that's why here for the from, you just see if, okay, if our first node, okay, not equal to 0. Okay, so not equal to 0 actually here just means if that 0 become false. So if first node not 0, this one is true. So this one, if you have first node, you just return the first node. Yeah, don't forget first node value. Okay. So else, what you return? Yeah, else if your first node, you don't have first node, actually we return dummy. So that's why you need to have your dummy value equal to assigned to the default value default constructor. Okay, so that's the from. So this one is very similar to the back, right? So actually the back is where you push at. So this one actually we check the last node. Okay, so if your last node, if you have last node, yeah, we just return the last node value. Otherwise, the same thing, we return dummy. Okay, so this two actually is for your front and the back. Good. So now, how about push now? So I just erase that. So how about push? So because remember, you can anytime you can pause your video. So I just go to the next one when we do the push. Okay, so this one, remember our push, we will push to the last node. Okay, so that's why whenever you have a new node, right, we still need to have a new node. So this new node, actually we were using the new node using the last node next point to the new node. So then the last node equal to the new node. Okay, so if you remember, this one is what we have before. Okay, so when we do the push, yeah. So your push, the same thing, we need to have a temp node. Okay, so this temp node is the new node. So this new node will have value. Okay, so if you want, right, so your next pointer equal to 0. Okay, so suppose that we need to add to the end, right? So that's why actually it's the last node next equal to the temp. Okay, so the last node next equal to the temp. So then your last node equal to temp. Okay, so that's the new node. But I want you to remind you, don't forget, actually this one is very similar to our copy last week. Because don't forget, you possibly have your first node as well. So that's why when we start for the queue, right, both your first node and the last node, they are equal to 0. So that's why when you really have a new node, right, we need to check on do we have our last node pointing to 0 or not. So if you do the last node equal to 0, right, so actually the last node equal to 0, not only we only need to assign its last node and the first node point to the temp. Okay, so that's why here we need to add one more thing. We always need to have the last node point to the temp. But here, this step, we have two situations. Because one thing is, if the last node, okay, we never assign any node yet. If we have the last node, right, last node next equal to the temp. But if not, okay, so here you need to be careful. Okay, so this one is else. If the last node never been assigned, right, so actually we need to have our first node equal to temp. Okay, so that's our push. So this push is similar to last week, you just remember. Because when the first beginning, remember both your first node and the last node equal to 0. You assign to 0. So if you really have a first node, that's the temp. We only need to do is both first node and last node assigned to the temp. But this situation is that really the very beginning, the first value we want to push to the stack. So that's why afterward you have your last node point to a node, right? So then last node not equal to 0. So then we will add the new node to the last node next. Okay, and also don't forget push. Sometimes we will forget after we finish. Don't forget your size need to plus. So that's push. Okay, so after we finish the push, how should we do the pop? Okay, so that's why you see your pop is from the first node, right? So we just need to find a way to have the first node point to the next one. So then we delete this node. So that's why actually your pop is the same as your before, like your stack. So if you have your first node, okay, so actually what we need to do is we still need to have a node temp assign equal to the first node. Yeah, okay, so if you're doing your pop, right, if you have your first node, so that's why your temp assigned to the first node. So then your first node equal to the first node next. Okay, so then here we delete our temp. Okay, so don't forget your size need to decrement by 1.